Hey guys, this is Eddie the Magic Monk. Welcome to another math lesson. Today we're going to talk about composite functions. And before we get started with that, I just want to remind you guys what a normal function is. So for example, if we have a function f of x is equal to let's say 3x plus 2, what that means is whatever number I input into the function, it will multiply that number by 3 and then plus 2 to give me the output. So if the input is, let's say, 4, so x is the input, which is 4, so what happens is f of 4 is equal to 3 times 4 plus 2, which is 14. So that's what you should know already. If you have no idea what I'm talking about, then perhaps you need to go back and watch the other tutorials. Okay, so now what is a composite function? Well, let's say that on top of our f of x function, which is 3x plus 2, I'm going to define a totally unrelated function. Let's say g of x is equal to let's say 4x minus 1. Now these two functions at the moment are totally unrelated, but what I can do is I can embed the function g of x into f of x. So now it looks like this. F of, so the input of the f function is the g function. Okay, so what does that mean? Now, for example, let's say x is equal to 3. So now this becomes f of g of 3. Okay, so what that means is I'm going to put the number 3 into the g function. So now I have g of 3 is equal to 4 times 3 minus 1, which is 12 minus 1, which is 11. So the input into the function g is 3, the output is 11, and then what happens is I'm going to get this output and I'm going to store it, I'm going to send it to the input of the f function. So now it becomes f of 11, which I will then need to take this number times it by 3, which gives me 33 plus 2, which is 35. Right, so that's what a composite function means. Getting the output from one function and put it as the input of another function. Now I can also write out this composite function algebraically by substituting the equation for g of x instead of g of x inside the f function. So then it becomes f of 4x minus 1. And then what you do is, instead of writing x inside the function f, what you're going to do is rewrite wherever x occurs as 4x minus 1. So then this becomes 3 bracket 4x minus 1 plus 2. Okay, so that is an algebraic expression for f of g of x. Okay, so let's try this with another example so that you guys are familiar with the concept. So let's define two separate functions. F of x is equal to x squared minus 3, and let's say g of x is equal to 2x minus 1. Okay, so what is f of g of 2? So that means that we'll have to substitute the number 2 into the function g of x. So then that becomes g of 2 is 2 times 2, which is 4, minus 1, which is 3. And then we substitute the number 3 into the f function, which makes it 3 squared is 9, minus 3 is 6. So f of g of 2 is equal to 6. Now let's try f of g of x. Okay, so what we do first is we substitute the expression for g of x, which is 2x minus 1, as the input for f of x. So this becomes f of 2x minus 1, which we will then have to substitute into the equation for f of x. So wherever x occurs, we rewrite it as 2x minus 1. So this becomes 2x minus 1 squared minus 3. Okay, so that is how you would deal with composite functions. So in case you guys haven't understood the whole concept of it, here's a definition of composite function. It is the output of one function used as the input to another function. Right, so that is the whole concept around composite functions. Visit our website magicmonktutorials.com to do some more quizzes and see the answers for